You ever wonder what's actually going on inside an AI's head? I mean, we talk to them, we give them prompts, but what if we could go deeper? What if we could actually steer their thoughts directly? Well, today we're prying open that famous black box to take a look at a wild new technique called activation engineering.
Okay, so here's our game plan. First, we're going to look at why our current way of talking to AIs just doesn't always cut it. Then we'll journey right inside the AI's mind, get a handle on what activation engineering is, see how it actually works, and then we'll wrap up by looking at what this all means for the future.
So let's be real. We're all getting pretty good at prompt engineering these days. But here's the catch. It's a very indirect way of controlling an unbelievably complex system. You're basically just giving instructions from the outside and, hoping for the best. And this right here is the absolute heart of the problem. When an AI gives you a weird answer or just completely makes something up, when it hallucinates, we don't really know why. We can try a different prompt, sure, but we can't get in there and fix the root cause because the inside is just a total mystery.
This slide just lays it out so perfectly. On the left, that's us using prompts to talk to the AI. It can be messy, it can be unpredictable, but on the right, that's the engine room. Those are the internal activations where the AI is actually thinking, and that's where the real problems are, but it's also where the real solutions are hiding.
So to make those real fixes, we have to get our hands dirty and actually go inside that black box. This means we have to move beyond the words we type and start looking at how the AI itself is representing concepts and ideas internally.
And that brings us to this whole field called representation engineering. You can kind of think of it as the science of AI mind mapping. It's all about finding and tweaking concepts like honesty, or maybe even creativity, that are buried deep inside the model's abstract internal map of the world. That map is what's known as its latent space.
And that leads us straight to the star of today's show, this very specific and incredibly powerful technique called activation engineering.
So activation engineering is it's like performing microscopic surgery on the AI's thought process. Instead of just talking at it, you inject a really precise mathematical instruction. It's called a vector, directly into its calculations as they're happening. A vector is basically a tiny compass needle, pointing the AI's thoughts in a very specific direction, like, say, be more honest. Now, this is where it gets really, really cool. How do you actually build this rudder? How do you steer the AI's mind from the inside? Well, the process is surprisingly elegant. It's a pretty straightforward three-step dance. First, you identify the internal brain activity, that specific pattern of activations that corresponds to a concept you care about, like honesty. Second, you take that pattern and you inject it right into the model's processing pipeline. And the result? That tiny new signal gently nudges the AI's final answer, steering it towards being more honest.
So how on earth do you find that honesty signal in the first place? It's genius, really. You have the model give an honest answer and you record its internal state. Then you have it give a deceptive answer and you record that state too. The mathematical difference between those two internal states, that is the honesty vector. It is the pure, distilled, mathematical direction of truthfulness.
And the implication here is just massive. It means you can take a totally normal prompt, but internally you're adding this little command to be more honest. You're not just asking for honesty anymore, you are engineering it directly into the model's response. You're basically forcing it to generate more truthful content.
Okay, let's just zoom out for a second. This isn't just some neat little trick. This could represent a fundamental shift in how we control and, frankly, safeguard artificial intelligence as we move into the future.
The benefits here could be absolutely transformative. We are talking about AI that is way more stable and predictable. It's a way to finally bypass all the guesswork of prompting and move toward an AI that we can actually understand and control, making it more reliable and way less prone to just making things up.
Yeah, this isn't just some minor improvement. Researchers are calling it a disruptive control method, and for good reason. It represents a total shift in philosophy. We're moving from trying to persuade an AI with our words to directly engineering its core logic.
Now, as exciting as all of this sounds, we do have to ground ourselves a little bit. This technology is incredibly powerful, but it is not showing up in your favorite chatbot tomorrow. Right now, this is very much on the frontier of AI research. It's complex, it requires some serious expertise to pull off, and yeah, the computational costs can be pretty high. The big challenge now is figuring out how we can get this incredible level of precision without it costing a fortune to actually implement in the real world.
And all of this leaves us with a really fascinating and maybe even a little bit unnerving question. We're starting with honesty, which, hey, seems like a pretty great idea, but as this technology gets better, we're going to have to decide what other traits, creativity, empathy, caution, we want to hard code directly into our AIs. What does it mean when we become the architects not just of an AI's behavior, but of its very mind?